ब्रह्माणान् ब्रह्मणस्पद आनः शृण्वन्नोतिभिः सीदसादनम् निषुसीदगणपते गणेषु त्वामाहुर्विप्रातमं कवीनां न ऋते त्वत्क्रियते किञ्चनारे महामर्कं माघवं चित्रवर्चा नमो व्रातपतये नमो गणपतये नमः प्रमथपतये नमस्ते अस्तु लम्बोदरायैकदन्ताय विघ्नविनाशिने शिवसुताय श्रीवरदमूर्तये नमो नमः हरिः ओम्
Thank you, sir. Let us start today's session. Today we are going to have handwritten character recognition and Vedanta Chatbot from C-DAC Bangalore resource people. Today's resource people are Dr. Vathsala H, Annarao Kulkarni sir, and Akhil Rajeev. On behalf of Vathsala madam, Nikhil is going to present today's session. Fine. So, coming to their biodata, Kulkarni sir has done his MCA from Karnataka University, Dharwada. His current status is working as Scientist F in Indian Heritage and Language Computing Group at C-DAC Bangalore since 2001. His areas of interest include natural language processing, corpus linguistics, data analysis, language technology, cryptography. Currently, he is working with the projects of translation from Hindi to Kannada, English to Kannada, using Sanskrit as an interim for natural language translation. Akhil P is an AI researcher with expertise in natural language processing and generative AI. Currently, he is working as a senior computer scientist in Big Data and Indian Heritage Language Computing Group at C-DAC Bangalore. He has contributed to language model development for Indian heritage and language and has a spread wide knowledge about innovative AI solutions for agriculture. I welcome you, sir. We are eagerly waiting for your session. Thank you.
Thank you, ma'am. Good to start the session. Starting with a very interesting topic. The talk is about the intersection of generative AI and the knowledge system. So, basically, as we have heard yesterday also, knowledge systems are basically regarding our ancient knowledge which has been preserved in our Shastras and other Indian Sanskrit texts. Also, it's available in other languages. Let's start the presentation. Start with the fundamental question: what is NLP? So NLP stands for natural language processing. As evident from the name, it is about understanding and processing a language syntactically and semantically. So going through it on a timeline basis, on the first stage, emergence of, so in the initial phases, the emergence of NLP completely manual. It was a human manual process, and it was started with the intent of standardizing any language. As quoted here, Ashtadhyayi of Rishi Parani, one of the works of NLP. You see technically, because before Ashtadhyayi came to the Indian subcontinent, Vedic Sanskrit was not a standardized language. It was there, but variation Vedic Sanskrit used to be different in different regions. What Ashtadhyayi did was it standardized the entire region under classical Sanskrit, which comes with fixed set of rules and grammars. And then like that, similar manual NLP tasks happened across the globe. But after that, coming to the modern centuries, about 300 to 200 years ago, we saw the rise of computers, and people thought, especially a company which is still very famous, IBM. IBM thought of integrating computers into natural language processing. Unfortunately, at that time, they were not that successful, but that changed when Alan Turing came into the picture. Alan Turing, for those who don't know, he's the father of modern computation and computers. So Alan Turing asked a question that what if we allow computers to understand human language? Now you need to understand one thing here, that whenever we talk about natural language processing, we talk only about natural language. So can anybody say to me, why do we need to explicitly mention language as natural language? Why can't we simply call it just as language? Yeah. Whereas when we say language in computation terms, it usually refers to programming languages. That's why, yeah. That's why we explicitly mention it as natural language. And post this, most of the experiments of Alan Turing were based on Russian. And after doing his experiments on Russian, he concluded that indeed natural language can be comprehended by computers. So that led us to NLP not being a side quest now and emerging as a prominent branch within AI. So what happened was scientists started taking natural language processing as a solid computational branch within AI. And slowly we saw the emergence of statistical and neural approaches. For example, we have the naive Bayes, we have the Markov trees, we have the various kinds of decision trees. So all of that was used to derive various kinds of NLP operations. And post that, what actually revolutionized NLP was the deep learning revolution. When deep learning got merged with NLP, we saw the rise of word embeddings, sentence embeddings, BERT, and all that. What deep learning essentially did to NLP was we no longer needed to manually code anything. Everything was automated, and humans could simply deploy models in order to do the NLP task. And finally, coming to the modern age, we have modern AI and NLP integration, which was, as you know, everybody, I don't think anybody in this room exists who hasn't used ChatGPT, right? ChatGPT is an NLP model. A lot of people say to me, I say to them, ChatGPT is an NLP model. They are like, no, it's an AI model. If it was an AI model, it would be doing computation, not generating text for you. So it is an NLP model, but the thing is, generative AI is an extension of NLP. It's not an extension of. Sentences are generated computationally, ma'am. But if you see NLP also, it's computation. Everything we have here is computation only. But one is text generation and one is mathematical computation. That is the difference. So for the that brings us to the next part of the presentation, which is I wanted to relate a bit with the National Sanskrit University. So I thought of comparing some core Sanskrit grammar concepts with NLP concepts. So for example, when we take the term of Vichcheda and the NLP concept of tokenization, they are not exactly same, but at the same time they are not really different also, because both of them involve splitting off a kind of literary unit into smaller units, and then they are used for further inference. Then Shabdarupa in then we have Shabdarupa. So Shabdarupa basically means reducing a word to its root form, right? And lemmatization is exactly reducing a word to its root form. So if I am taking a word like going, then it gets reduced to its root form of go if I apply lemmatization on it. And similarly, if I take the word gachati, it gets reduced to its root form gam if I apply Shabdarupa, right? So this is an exactly same terminology. Then we have vibhakti. For example, we want to identify any kind of grammatical case, whether it be subject, object, anything. Then we use vibhakti in Sanskrit, and we have morphological analysis in NLP. Then for any kind of determination of noun, verb, adjective, gender, number, person, etc., we have linga, vachana and purusha in Sanskrit, whereas we have POS tagging, part of speech tagging in NLP. Then we come to sentence generation. Sentence generation can literally be translated to Vakya Rachana in Sanskrit. It's literally word to word translation. And as evident from the name, it means automatically generating correct and meaningful sentences. Then we have Chandas. I have worked personally on Chandas, and I must say that Sanskrit language has one of the most elaborate meters across the world. So Chandas helps us in recognizing poetic meters like Anuštop, Tristop, etc. And same meter detection also exists in NLP. Then we have Arthabodha. So Arthabodha exactly means like you have a certain document, you have a certain text, and you want to take the crux out of it. You want to know the intent of that message. And semantic analysis in NLP does the exact same thing. So with that, we move to generative AI part. Now I want you to look at it from this perspective. What is exactly generative AI and what differentiates it from traditional AI? So for traditional AI, we have to train the entire data set. But for generative AI, we train it on a pile of data set. But the testing data, the data which we actually put into it for question answering is different from the data on which it has been trained. Because the traditional AI, it does only prediction and classification. But generative AI does generation. So classical AI cannot mimic human creativity, but generative AI can mimic human creativity. It creates new content, whereas the old AI, it only can follow the certain rules which have been prescribed to it. Then these are the most common use cases for generative AI. It can write poems for you, it can write anything for you, it can write stories for you, it can write essays for you. And in drawing, we have generative special models like GAN, generative adversarial networks, stable diffusion. These generative AI models can be used to create images. Right now, that Ghibli trend is going on. Ghibli is another example of generative image models only. Then we have conversational AI. I think National Sanskrit University is involved in speech recognition and augmentation, right? So we have chatbots, we have LLMs which can actually hear speech from your side, it can transcribe for you, it can speak on your behalf, it can convert from one audio to another audio. All of this can be done by generative AI. And finally, the most important thing is this is not an application, but it's about learning. An actual good generative model, it is always on a feedback loop. That is the point which defines a generative AI model. If it's not on a feedback loop, it will fail at some point. But when it's on a feedback loop, it always keeps running on that loop and learns from its mistakes. So that makes sure that the model always remains top notch. Then coming to generative AI as an extension of NLP. Now that we have had an overview of both generative AI and NLP, let's see how they actually connect with each other. So for example, in NLP, we have NLP helps us in understanding text and speech, whereas generative AI helps us in creating text and speech. So even from a human perspective, okay, if you are able to understand a language, you will be just able to understand that language. But if you are able to speak a language, is it possible that you don't understand that language? Is it possible? If you are trying to write or speak a language, you automatically understand that language, right? That is exactly the thing which is happening here. NLP helps you understand the language, and generative AI helps you in creating that language. So it's like an extension of NLP. That's why I said it's an extension of NLP. Then NLP can help you in translating from one language to another language, whereas generative AI can help you in not only understanding from one language to another language. It will definitely help you do that, but other than that, it can also help you in writing stories, poems, or anything, because we are understanding plus generating. Then when it comes to NLP tasks, we can only analyze the meanings and grammars from it, whereas for generative AI, we are able to mimic entire human creativity of writing. If you train a generative model on a certain kind of data, it will be reading the patterns of it syntactically and semantically and mimicking that same pattern while generating the texts. Then finally, when it comes to question answering, what NLP can do is, if you give it a data source, it will be just taking whatever is relevant from the data source and retrieving and giving it to you. That is all NLP can do. But when it comes to generative AI, it can not only take from the data source, it will take the context from the data source and generate solid human answers from it. That is where the difference actually comes. So I'm not sure, you guys might be knowing better. This was just an improvisation. As Rishi is saying, NLP tu bhashya bodhanam karoti, generative AI tu nutan vakyanam shrishtim karoti. So basically NLP helps you understand and generative AI helps you make it. It's right? Then now that we have understood how generative AI and NLP are, we can come to how they actually understand what we want them to understand. In order to understand that, we have to understand the transformer architecture, which I won't be going through because it doesn't make sense. We don't have that time to make you understand this architecture. I'll be simplifying. Basically, if we input, is there any way to remove this? No. Okay. So if we input a certain text from here, okay. If we input a certain text from here, then the input gets converted to input embeddings. These input embeddings are stored in a latent space. So by latent space, I mean there is a 3-dimensional space. Yeah. There is. It's fine. So we have a 3-dimensional space. In that, the entire embeddings get stored. Embeddings are nothing but representation of that words, and they get stored in a vector plane. After that, we are able to pass it through a positional encoding. What positional encoding does is, it allocates a certain priority to each and every token, each and every word which is present in that sentence. After that, we have two parts here. The one which you see here, it is called the decoder layer. What we see here is the encoder layer. So the model passes through the encoder layer, and the encoder layer encodes the input, and the decoder layer decodes the output. Post that, it is passed through an activation function like what you see here, softmax. Yeah, so what you see here as softmax, this is actually an activation function. After passing through the softmax, you get your output. So this is basically how transformer works. This is the most simplified explanation of how any generative AI model works. So now let's get a superficial understanding of how any word is generated in generative AI. So we'll come to this slide. So this is a pre-trained transformer. Okay. So if I ask it, once upon a time there was a. Okay.
You gave an example previously.
Yeah.
So this is transformation.
I'll come back to it. Because
word to word translation does not apply there.
How
are you coming to that result is what I want to ask.
No. Here no. This.
Yes. See, how is hai. Hindi. You is aap. R is not kaise. Right?
No. But that is the difference between language. No.
And again, tailoring should be done. One thing.
No, that sentences are tokenized. There are byte pair encoding and sentence piece encoding. So initially it generates the tokens.
Okay.
So the key token is nothing but a small string of small strings. Yes. For each string, and it's converted into numeric. Integer is assigned to the machine automatically. So in the encoder input layer, what happens? Encoder layer takes the input, and that decoder layer, whatever is there converted. Many loops are there, right? At the attention layer, and the feedback from whatever the numeric values are converted from here is fed to the decoder, and the decoder both the source and the target languages are fed. So it automatically learns.
So basically, what you.
Actually, the question is how the machine selects off for you. To and off are the equivalent translations. But since it is machine learning algorithm,
Yeah.
depending upon the most frequently used
Yeah. What is happening here is happening organically. We are not doing it. Because when you train the model on loads and lots of data, when I'm training parallel corpus of English and Hindi, that machine learning model automatically gets that intelligence to generate the equivalent. We are not doing anything in that. So yeah, coming to this one. So this is basically a pre-trained transformer. What we have here is a neural net, a regular neural net. So what happens is, once upon a time, there was okay. Now, if this is given as an input to the transformer, what it will do is, we are assuming that it has already been trained on a bunch of data. So we will be, the next token which will be generated, it will be giving a certain probability. So as we know, probability is between 0 and 1. So here we have Brave with a probability of 0.35, Magical with a probability of 0.25, and Village with a probability of 0.2. So naturally, since Brave has the highest probability, it will automatically select Brave. So you have, once upon a time, there was a Brave. Then
Out of 100 occurrences, 35 times a brave word has been selected in the past. Suppose if you have king, once upon a time there was a king, then there is a chance of.
Yes. Because it is a probabilistic model.
it's a probabilistic model. And this, ma'am, another thing is this probability. This is not decided by us. This comes out organically from the model when we train it. So
So in case there are two values which have the same probability, how does the system decide what to go?
that's where another concept comes. It's called model hallucination. So the model hallucinates, and you will get wrong outputs also sometimes. That's why if you even see ChatGPT or any of the Grok models or Llama, anything, they have a small little heading below. This is a generative AI model. Please do not take it as it is. It may be prone to errors. Even the highest models are prone to errors because every model hallucinates. The architecture itself is like that. Then like following to that, so a Brave, then it has another probability, Knight 0.3, Warrior 0.1, Sailor 0.15. So finally we have a full sentence, once upon a time there was a brave knight. So this is the generative part of the transformer. So what we usually use three kinds of transformers. One is encoder only transformer. As I explained before, we have an encoder layer and a decoder layer in a transformer. So encoder only transformers have only an encoder layer inside the transformer. These are usually the transformers which are used in BERT. You might have heard of BERT, right? BERT, distal BERT. All of them use encoder only transformers. Whereas then we have encoder decoder transformers. What you see in the previous slide, this is an encoder decoder transformer. That's why it is able to translate, because translation is an encoder decoder task. You have to first encode into embeddings, convert that embeddings into another plane, then decode it to get the Hindi output. That also explains why, despite them not being exactly same, it is able to map it exactly, because on a vector plane all of them are same. They are not linguistic anymore when they are in embedding form. So that's what is written here. Input reads the sentence word by word, and then, for example, here, how are you? It will be assigning the priority. Okay, I'll give the highest priority to R. So the context shouldn't get missed. So as soon as we give the highest priority to R, it made sure we have aap kaise hai, that context remains preserved even if the language changes. So that ensures us the best possible translation. Before this, we used to have NMT architecture models. The issue with NMT was it used to work on RNN architecture. RNN had this issue that it used to lose context after a certain point. So they used to fail in languages when the language structure changed, because the language structure of Indian languages is very different from the language structure of European languages. But this issue was finally solved by transformers.
So Hindi is predominantly a positional order.
Yeah.
Whereas Indian words are pre-order.
Free order, yeah, exactly.
Another problem with English is that unfortunately all nouns and verbs, the same word act as a noun as well as verb.
That is there in Sanskrit also. Gerunds exist in Sanskrit also.
We have prefixes which you are saying that the same word acts as noun and verb in Sanskrit also. English, for example, I have control,
Uh-huh.
control him. So control, noun control, verb control, their word form is same.
Okay.
Depending contextually, we have to fix whether the control and word control and the now consideration is whether it belongs to either noun or verb.
Yeah, that makes sense. Yeah. Yeah, we can calculate the error and loss in transformer models also. Well, there is no difference in that. The only difference is in the attention mechanism. In transformers, we have attention mechanism. In RNNs and LSTMs, we don't have any attention mechanism. That's what makes the difference. So, for example, if I'm writing Akhil is presenting at NSU. So, if it's a RNN or an LSTM, what it will do is it will go from Akhil. But for transformer, since it has an attention mechanism, it has a self-attention mechanism, what it will do is it will target the keywords. So Akhil is presenting at NSU will be Akhil, one keyword, presenting one keyword. The focus will remain on those keywords. So when the focus remains on those two keywords, the context remains preserved. That is what makes transformer special. And so coming to the types of transformer, that's what I was explaining. We have three types of transformers. One is this encoder only transformer, which has only the encoder layer in it. Then these kinds of transformer, the most famous example is BERT model, which is used very frequently nowadays. Then we have the encoder decoder transformer, which is usually used for translation tasks. And a famous model from encoder decoder family would be T5 by Google. Google's T5 is pretty prominent. It's an encoder decoder transformer. Then we have the most famous type, which is the decoder only transformers. Since decoder only transformers have only a decoder, they are not able to encode text to that level of extent. The decoder layer has a small encoder mini layer, that's all which is used for encoding. So these kind of decoder only transformers are useful only for use case when we are generating piles of text. We are generating piles of text without any change in language or order or anything. So, for example, any kind of conversational chatbot, any kind of generation, if it's required, we will be giving decoder only transformer. So, the most famous transformer comes from this family, which is GPT. Full form of GPT is generative pre-trained transformer. So, GPT belongs to decoder only transformer family. This is a more broader difference between all the three types. If someone wants to go through it, you can go through it. I won't be, again, it's a bit technical, so I won't be explaining it on stage. If someone wants to understand it, they can meet me in person, I'll explain. So, yeah. Yeah. So now that we have got a complete overview of transformers, we come to those kinds of transformers which have been trained on billions, petabytes of data. These are the transformers which we call as LLMs. Okay, so these transformers models which are pre-trained on potentially hundreds of petabytes of data, they see trillions of examples. So basically how a baby learns. When you are a kid, you don't know what is Sanskrit, you don't know what is Hindi, you don't know what is computer. But gradually after seeing it again and again, as like I think a lot of you had attended that reinforcement learning session which happened last, sir was also saying the same thing. As a kid, when you grow up, you see a lot of things, and those things kind of act as a recurring loop in your brain, and that's how your brain learns. Similarly, there we have neurons, here we have neural networks. The neural networks also learn in a similar way. And basically that's how a baby learns. And ma'am was asking, no, like what is the probability, how do we put the probability? That is still a mystery, that's a black box, no one knows about it. It's just that when we train it on a lot of data, it automatically organically generates how to prioritize certain words.
How many times the word can be labeled among the classification categories.
But That is. So that brings us to the superstar of the Gen AI world, large language models. They're everywhere nowadays. So that's why. But you should never fool yourself to believe that large language models understand anything. They don't understand anything. They don't understand anything. They are stupid machines which are generating words based on a certain probability. That's all. So we have parrot here. Parrot is called shuka in Sanskrit, right? So here Mr. Parrot explains it very beautifully. So me no understand, me just predict. Okay. You say once upon a me squawk time. Not smart, just seen it before many times. Me no think, me complete the pattern. Big brain no, big mimic yes. It's just mimicking, that's all. So these are the major kinds of transformers. We have OpenAI's GPT, Google's BERT. Gemini model is also picking up. Then we have Meta by Llama. And yeah, that was the main disclaimer I wanted to give, that despite all this technology, you can't take Gen AI, even though we call it generative artificial intelligence, there isn't the actual intelligence. That human intelligence is missing in generative AI. There is no artificial intelligence. If machine actually had intelligence, it would be called artificial general intelligence, not artificial intelligence. So yeah, with that I conclude my part. Now handing it over to Annarao sir. No, continues. Now he'll be telling about the applications of AI and showing the implementation.
From yesterday we are talking about large language models, what is AI. The problem is the current. So we have been talking about large language models, natural language processing and all. What is the problem with the current large language models is that you need a huge data to train the models. Okay. So Government of India is coming out with India AI and trying to build the foundational models by India itself. So the challenge here is you need a huge data. That is the challenge here. So the challenge with the large language models is that you need a huge data, but the current research is going on why you need a huge data. Take for example in Hindi sentence, वह खाता है and वह खाती है. So वह is same, the pronoun he and she, in Hindi they use वह only. But when you translate from वह खाता है and वह खाती है, the machine will translate he eats and she eats. So how the machine learns वह is referring to he and she, that is attention basically. When khati is there, the attention is given that it should be replaced by she. And if it is khata hai, then the vah is referring to he. To learn this syntax by the machine, you need a huge data. So why you need such a huge data? A person can understand by conversations. As sir was telling, based on the action and the pronunciation, the kid will learn the sentence, right? So, but that is not the case with the machines. You need a huge data to learn the patterns. So the current AI is based on the patterns. The given text is tokenized and the attention is given to each token, and finally the machine will learn the language. That is how the large language model works. So currently the large language models existing, they are already learned many things available on the net. So what we are going to show now is how the large language models can be used for the education purpose by Vedanta Chatbot, what we are presenting here. So whatever the output it is generating, so what we have done is Vedanta debater, through which you can ask the questions based on the related to Vedanta topics for 3 matas, Advaita, Vishishtadvaita and Dvaita. This can help the students to get some insights. Ultimately, it will not replace the scholars, but for the education purpose, LLMs can be used to get some insights into the topic. Okay. Yeah. So now Akhil will be presenting how this chatbot can be used.
Hello. Yeah. So we have developed Vedanta Chatbot, and we will be giving a POC implementation of that. Basically, we have three major schools of Vedanta: Advaita, Vishishta Advaita, and Dvaita. And we are basically, the LLM is able to debate on behalf of whichever school is selected. So we'll be giving a sample implementation of that. This is the quick overview of the tech stack used. The backend is using Llama LLMs. The user interface has been created with Gradio GUI, graphical user interface. And the main AI methodologies which have been implemented here are pipeline optimization and prompt engineering. So with that, let's start with the implementation. No. This is completely on my side. It is tech stack. It is the. No, it's not concerned with how to ask a question. It's concerned with how do you give the system prompt to the language model.
Basically, you are telling the machine to fetch the answer from particular domain.
So this is Paramutkarsh supercomputer cluster at C-DAC Bangalore. We have hosted it on Paramutkarsh, and we will be showing the demo to you right now. I've explained. Just a few minutes. I'm just loading it. Yeah, you can summarize, no issues.
Madam told that it will be completed within 10 minutes.
I'll show it.
Will it take time? At least 3 minutes up to 5 minutes?
By that time you can summarize.
Good morning. And Akhil explained about generative AI, taking with an example of transformation model. He has explained with the transformation model. For the input is this general sentence in any language. The output is, if it is translation, the sentence in the target language. So when this process is going on, when the sentence is first fed to the system, it takes the sentence and it completely derive the entire information into machine processing form. That is the function of encoder. So from that point onwards, it will not consider the input given. So based on, and it also involved with, and it is saying that transformation model, it will not process strictly more than necessary, and before that machine is given data sets with input and output examples. That's how machine learns. I would like to tell, because the audience are new to machine learning. In machine learning, whatever be the problem, the sets of question and answers, input and output is given in a large set of as a large set of examples. The computer tries to, it takes the sequence of the words or sequence of the words, and it sees how to derive to the output. So based on that, it learns on its own when input and output examples are given. For example, vah khata hai, vah khata hai. Suppose the sentence is he eats, even though it is word by word translation, vah has many interpretations. She, he, it, that, like that. So out of 4 combinations, how it will select? It selects based on the previous examples, because the word is eats. So it is maybe first third person singular. So again third person singular. It can be masculine or feminine. So it takes the probability by machine learning examples and it decides. That's what he was saying. And decoder is, when encoder converts the given sentence into abstract computable information, it takes, decoder takes the input from this transformed intermediate representation of the input, and from there on it works. And it decodes, tries to generate the given answer or sentence, whatever it may be the task at hand, it produces into the sequence of output words. That's how. So in meanwhile, there are many concepts: contextualization, machine learning, probability calculations, keyword in context. For example, if you say this car drinks petrol, even though drink is a human activity, when it is attributed to the non-living thing, it has the correct. Sometimes, if you don't, even though it is word translation, if the sentence is not understood fully, the translation will not be perfect. For example, the men murdered the women; they were caught. The men murdered the women; they were buried. So caught and buried. Who were caught? Who were buried? Suppose if it is to Sanskrit translation, they should be te or taha. When they were caught, since men murdered the women, so there is men. They were buried. Since the women were dead, so they were buried. Men murdered, so they have to be arrested. So whenever the arrested comes, the word comes, it should be te. Arrested comes, it is tha, because depending upon the as soon as you finish, you just tell me. Depending upon the the combination of the words in the sentence, the now pronouns should be disambiguated properly. That's how he told. Thank you. And
thank you, ma'am, for the quick overview. Now we can proceed with the demonstration, I think. Share screen. Okay, so it's two. So it's loading. They can come. Shinchana I'll take. Hold up. Shinchana. No, we will ask Rand. Why is it not load? It's not loading. That GUI is not loading. Then is the net slow? Is the net is not able to load the GUI? 100 Mbps. Is there any firewall here? Yesterday it was working. Meanwhile, Nikhil can give that. I'll check. Let him. Yeah. Gateway timeout. Okay. Let me see. Meanwhile, what is he? What are you presenting? It connects here. Screen present చేయాలి. ఈ ల్యాప్టాప్ చూపించాలా?
morning, everyone. I will be demonstrating the project Nandinagari palm leaf character recognition. Firstly, I will show some of the images of manuscript written in the Nandinagari language. Ma'am? Yes. This is a manuscript images which I consider for the trained model. It will be used for character prediction. These are some of the manuscript images. Demonstration. This is a original image written in the hand. I will be processing the image using some Gaussian blur and some processing technique using Savoy thresholding. I'll be getting this image like this. After processing, I'll getting this image as background as white and presented text as a black color for future prediction of letters. Then I'll segregate each line as a separate image for classification of letters. Like this, each line in that manuscript, it has 6 lines. It will be segregated 6 lines as a separate image. This is the last line. After that, I'll give this each line to for the contour detections.
As we know, there are different scripts, Devanagari, Nandinagari, and so many scripts. So the OCR, building OCR for each of the scripts has different challenges. So here what we are trying to demonstrate is we want to build OCR for a handwritten character recognition for Nandinagari. So that is because many times this family manuscripts are damaged. So you need to reconstruct in such a way that whatever damaged portions are there, you need to cover and then you need to extract those characters. So in the full demo, what he is trying to show is if you have those family manuscripts which are written in the Nandinagari script, so how to extract those characters, how to build the OCR with this. That is what he is trying to demonstrate.
Yes. After segmentation, after getting the each line as a separate image, I'm giving to the counters. It detect all the letters in the particular image like this. In the green areas are the saved as separate image for the text. Second line. Third. After applying contours, all the letters have been saved like this for all the lines. I'll select the first image, the original image.
Shall we both do these things?
Yes.
Let me talk to you and let me know. Actually, this is an image this comes under image processing, computer vision. What actually is, there are palm leaves. Suppose if you want to make use of it, you have to take the palm leaf by leaf, and you have to type on the screen. That takes time. So in order to automatically do the things, they are trying to feed the palm leaf as input to the system, and they will get it as a PDF file or document file, which can be edited, which can be corrected as per this thing. And he has shown the palm leaf like this. This is the palm leaf input, and stage by stage we have to do. Second stage is when this is given to the system, a series of programs, applications, then it will try to first separate line by line. The first line is separated, second line is separated, third line is separated, and every process is repeated for every line, so that every character of each line is to be retrieved or identified. Sometimes we may wrongly identify, or sometimes we may rightly identify. So as a first stage, when it is given to a program, show me the second. And program, and it doesn't seem, it is not that easy to do even though if I say it in English, it may look like a very small problem, but it has so many open problems. Okay, that are pre-processing techniques, and we are not.
Yeah.
So it is converted to grayscale first.
First it will convert.
Converted to grayscale, then to the line segmentation. There is a challenge actually. The English is linear, but the Indian languages we have 4 layers. The first level, then the top level, then the 2 levels down. That is the challenge. So that is a different story. One of the tasks is converting whatever the images to text, but there are some broken places. Then
And one challenging is converting, for extracting each line from the palm leaf is, suppose if you take English script, line by line, there are no upper marks and lower marks. What do you call that? Actually, the entire, suppose if I write, matras will be sometimes on the upper side of the character, sometimes on the lower side of the character. So when line is to be recognized, some and certain letters will not have any upper and lower parts. So that is a bit difficult task and challenging task when compared to the English. And that line separation is called line segmentation. Next part.
After line segmentation, I've given this each line to the counters. That counters detect all the characters in that
Show
image.
you. On the top side of the program, you are see each line is bordered in a green rectangle. That means it has segregated the letter, not yet identified. It has segregated the letter, and that will become the input to the character identifier. And that's how the thing will be done. And again, the entire activity is integrated into getting back the palm leaf in Word format and editable format. Images cannot be edited. We can see, but suppose if you want to edit, and if you want to make use of it as the thing, we have to do it. That is the application of character recognition. Yes, you know the subject very well, but there are many Sanskrit students, they do not know. And if at all your questions will be answered at the end. Afterwards, after completing the next. training algorithm.
Find out the contours also actually. So that is the process. Then afterwards, whichever model you want to apply, maybe deep learning, artificial ML, anything you can apply for transmission. It will come out.
After applying the contours, I given that each created actually 92 classes of image, almost 1,200 image plus, and I trained that images and I predicting the letters according to it. This is the predictor letters belongs to that particular image of each line.
So here we are using machine learning techniques. So once the green letters were given, they had to be converted into editable form, and that representation is called glyph. So these people will train, will give examples of this letter with many modifications. The same pa is written in many ways depending upon the writer's style. So all those writer's styles are fed along with the actual glyph, and whenever in whichever way it is written, we will be able to identify. See how face recognition works. Normally we people see the face as a single image, but when it is given to the system, it measures whatever be the size of the photo or picture, it tries to take it into a normal form and see with the total width of the face, the length of the nose, it has some parameters on its own. So that's how, if that if it is the nose of that particular photo, likewise they have some inbuilt, and even sometimes when given for machine learning, it identifies its own parameters that are called feature recognition. Yesterday Varangal professor was also saying feature extraction is the most important pattern, and in any machine learning algorithms, pattern is very much important. So whether it is text or it is voice or image, whatever it may be, the patterns are to be trained against the real output. Correct ga cheppana?
After getting all the contours as a separate image, I given to that contours to the convolutional neural network having 512 neurons belong to it. Each neuron is going through all the classes over there with a deep curves and all for predicting the classification of the particular class. After predicting only, it displaying all the characters here. If the character is wrong in the middle of that, we can use the keyboard. We can edit the characters over here only, like this. We can edit the character, each character if you want, in the middle also, in the however you want. Then if some images has been, some characters have been combined with together, like for that. See here, two characters as combined in one contours. The model will not predict the exact character there. For that, I have used cropping in image in the real dynamically. We can segregate this character like this, and these two characters, and it will be saved as a separate character. See here, the two characters has been separated. Then if we again predict the letters, it will be predict according to it.
Yeah. In complete chess anybody.
So even though because of some technical issues, the demo is not working.
Sir, well, let him complete. Let him complete.
It will separate. It will print the character exactly. Both the manuscript is there.
In any machine learning algorithms, there are two distinct processes. One is categorization or classification. One is segregation. So here, whatever be the input is given, we have already this combination of many letters. For example, if you say ka ka ki ki, ka ki ka 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 ki ki, Vitraksharam, so there are all possibilities. So against all possibilities, the word may be checked and computed, and the character under consideration is correctly mapped. In any case, if it is not mapped, he has shown the image of one letter pya. Pa, ya, because of the complexity of writing, they are not able to whether it is pa, na, ta, na, like that. They have, even single letter has been segregated into two and again given for classification, and correct glyph is, correct letter is predicted.
Yes, yes.
Then,